Hi Monica, so I thought I'll just quickly go through your questions. They're all fairly straightforward apart from the second question, which I'll go through. But the first one, now I tried to find the 26A2, which is the probability, but there was no probability there for 26A2. So I've tried 25A2 just in case this was one you're meaning. For this question, what is the probability that the second card in arrangement is a J? Well, from the first question, it asks us how many ways can be arranged, which is in this case will be 3p3, which would give you 3 times 2 times 1, which is 6 combinations. But if I actually draw them out, we get MCJ, MJC, CMJ, CJM, and then we get JMC and JCM. And this one helps us with the second question, because all we need to do is see what arrangements they have a J in the second case, in the second letter, should I say. So we have a J in that one, we have a J in that one. So we have 2 in 6 chances of it being a J, which is 1 in 3 chances of it being a J. Okay, so that's question 25A2, so I'm not sure if that's the one that you're meaning about. The next question, which is on 2009, question 27C, this is the more challenging question, which is a little bit tough. For the first part, we know Mary buys 2 tickets in one raffle, and we know that there are 100 tickets in that particular raffle. So we have 2 in 100, or 1 in 50, or 0.02. If you want to compare, it's probably better having it as a decimal. The next bit is a bit more challenging, because this one, for most cases, what people would do, they'd do 1 over 100 in chances of getting that one, and 1 in 100 chances. Unfortunately, that would give us 1 in 1,000. That's actually incorrect. This is a tough one. What we have to sort of look at is look at the probability of her not winning, okay, and then see what's left over to make up to one whole. Okay, in other words, we're going to subtract that away from one whole. So what's the probability of her not winning that first one? Well, if it's 1 in 100 of winning, it's 99 out of 100 in losing, and then it's 99 out of 100 in losing the second one. The issue when we do 1 times 1, it's only going to give us 1, and that's a little bit misleading, this question. So if I do this and I do 99 over 100 times 99 over 100, which will give us the probability that she doesn't win, okay, that she doesn't win, then if I subtract that from 1, that should give me what the probability that she does win, which will give me a, I think it's 199 over 1,000, or so 10,000, which as a decimal gives me about 0.0199. So looking at those two decimals, we can say Mary has a better chance of winning because 0.02 is higher. Okay, that is a really tough question, a very tough question. The next one I looked at is 2010, question 26A2. Okay, for this question, we're looking at these number plates. We know that we have, if we look at the place where we have the number plates, we have 10 opportunities in the first place, 10 opportunities in the second place. Generally, we'd have 26 and 26, and then 10 and 10. However, we know that we want to find what the probability of having Joe in the middle. So we know that we can have Joe there, so that's already been chosen. So there's only one option in the middle, but it's saying that we want to have any options that has Joe. Okay, so let's have a look. We got we said 10 options for there, 10 options for there, 10 numbers there, and 10 numbers there. So we're looking for how many different combinations have Joe in the middle. So 10 times 10 times 10 times 10 gives me 10,000 different combinations. So there are 10,000 number plates that have Joe in it. What we want to figure out is what the probability will be that she has one of these two number plates. Well, there's two number plates that she wants, so we have 2 in 10,000 possibilities, which obviously goes down to 1 in 5,000 chance of probability. So again, there are 10,000 number plates with Joe in the middle by getting 10 times 10 times 1 times 1 times 10 times 10. And then there are only 2 number plates that she actually does want, so obviously it's 2, it said 2 in 10,000. Okay, the next question I looked at is 2011, question 24B2. What is a relative frequency? Well, relative frequency looks at, well, it's the same as experimental probability, so it's not what should happen, but it's what actually does happen based off results, and these are the results we've got here. So if I look at my number 4, we have 8 falls that have occurred. So we have 8 out of all these numbers, so 8 out of 72. 8 over 72 would cancel down, I believe, 9 8 to 72, so 1 over 9 would be my probability in that case. Alright, so relative frequency is the same as experimental probability. It does say there, just in case you had question 3 as well, if the die was unbiased, which number was obtained, the expected number of times. Well, if I looked at theoretical or expected probability, well, if I've rolling at 72 times and there are 6 numbers there, I would suggest that we have, what's that going to be, 12 times each one would have occurred. So in this case, 5 would be the number that has the expected outcome, because that's got 12 times. Okay. Next one, 2001, question 8. So going into our data now, so multiple choice. The following frequency table shows Rav Deep's scores on a number of quizzes. Okay, so we're looking for the mean score. Now, usually what we do, put this into our graphics calculator and work out what the mean is. If you only know how to do that, what you can actually do is just put these into your calculator, each one, and find out what the answer is going to be, and then just see which one's the same. But if we do this properly, the way that we find our actual mean is by doing our fx column, our frequency times the score, because that means we've got 2 lots of 1s. So I've got 2 lots of 1s, which gives me 2, 3 lots of 2s gives me 6, 5 lots of 3s gives me 15, 2 lots of 4s gives me 8, 1 lot of 5 gives me 5, because basically that's saying that I've got 2 1s, 3 2s, I've got 5 3s, I've got 2 4s, and I've got 1 5. So that's where those scores are. So altogether, if I add up all my scores here, which is all this lot here, or that lot there, so 2 plus 6 plus 15 plus 8 plus 5, and then I divide by the frequency, so how many times I've got it there, which is this, so 2, 5, 10, 12, 13, and as you can see from that part there, I've got 13 numbers there. I divide that by 13, you can see the answer is actually A. 2 plus 6 plus 15 plus 8 plus 5 divided by that 13 numbers. Okay, so that was a slightly more challenging question again. Okay, the next question that I looked at for you was the 2003 question 12. So again, looking at some data. Okay, so use the following information to answer this question 12 and 13. You only put 12 there, so I thought that one is one you wanted. Now again, I told you with this type of question is to put it into your graphics calculator, make it so the stat mode. If you put it into stat mode, making sure you have this as your list 1, which is your X values, and you need to make sure you go into your frequency. So you go into the set and make sure your frequency, because you're using a list, you go into list 2 for your frequency, and then you can just type these all in, press your calculate key, and then let it calculate the mean, which will be 1.15. If you didn't want to do it that way, you want to do it the long way, if you times 5 and 0, we get 0, 10 times 1 is 10, 2 times 3 is 6, 3 times 1 is 3, 4 times 1 is 4. Like that last question, we add all these up together, which gives me 16, 19, 23, I think. I've done that correctly. And then we need to then divide that number by however numbers there are, or 5, 15, 18, 19, 20. So 23 divided by 20 equals 1.15, which should be the answer you got using your graphics calculator. Okay, 2007 question 9. Which of the following would not be most likely to have positive correlation? Now, we haven't looked at correlation too much. We looked at it last year, so this probably won't be in your exam, but either way, I'll do it. If we look at our linear equations or linear graph, a positive correlation means that my scatter graph goes in a positive sort of direction. So what this means, as my x increases, so as x increases, y also increases. So for example, if the population of a town and the number of the schools in that town, so the population, if the population increases, what would you expect the schools to do? Well, most likely, if the population increases, the schools would probably also increase. So automatically, I'm going to say the answer is A. If we look at the price of petrol, if the price of petrol per litre went up, what would you expect the numbers of litres sold? Well, that would probably go down because less people would be buying, so that would be a negative one. The hours of training for a marathon and the time taken, well, if I look at the number of hours, doesn't matter which way I'll do it, if I do it this way, the number of hours that increase, well, the more training I do, the less time it should take for me to actually make the run. So again, that should be a negative correlation. And the number of dogs per household and the number of televisions per household, well, they really have no correlation whatsoever because they shouldn't affect each other. So that'd be a no correlation question. But again, that won't be in the exam, okay? But you know how to do it now. And the last one, the area graph shows the costs and profits for a business over a period of time. It looks at an area graph. The most important thing with an area graph, the costs is that lighter colored one. Okay, and you can see that, you know, if at any point, for example here, the cost is much greater than what the profit is. Okay, and you can see here the cost, I guess, is going from small to, so a small area to a big area to a small area to a big area to a smaller area. Now you'll notice pretty much for most of the costs, you can see they show that small to big, small to big, small to big, etc. As for most of the costs. The issue is with the profit. I'll do that in a different color. What you'll notice in the color, so the profits, this is a relatively same sort of width, I guess. So it's pretty much the same size, maybe slightly getting a little bit bigger. And then what you notice, that the area starts getting smaller and smaller and smaller to nearly non-existent. So which line here shows that it's getting smaller and smaller and smaller? Well, it will be B, because you can see that that profit line is going smaller and smaller and smaller and smaller, as you can see that area is doing there. And so again, it's called an area graph because we're actually looking at the area of that particular amount. They love putting these questions in, particularly like having percentages on them. For example, they might have percentages up on the y-axis here. And they might say like, that, for example, is 10%. That up here might be 50%. That here might be 40%. And they might say what's in 1990. What was a percentage of the profits, for example? The profits would only be this amount here, so that amount would be about 10%. Okay, whereas the bottom amount might be 30%. So just be careful. They can ask different types of questions in terms of that area graph. That's a pretty cool question that they love sort of putting that one in there. But yeah, anyway, look, I hopefully that helped and cleared up most of the questions. If not, put some more on Edmodo and I'll see what I can do. Alrighty, hope that helped. Good luck for tomorrow, and hopefully if any more issues, I will see you in the morning at 7:30.